I have a really nice pot here. This is a 25 ohm 3-watt wire wound. I think you'd hear it when I turn it. I'll try. It's a really nice one. And what I'm going to do for the temporary circuit is when I hook these wires together to build this up, I'm going to make this in line between the two. And this is going to provide the balance that I require. This is all just going to sort of hang out and be taped and isolated for the test circuit. What I want to do though, just because this is all brand new, is I'm just going to get an ohm meter out very quick and find dead center of this and split it in half. I want to come into this making sure that I have center on here beforehand. And there we go. That's all there is to it. Everything's in place, pot centered. Everything is wired up now for one of the taps to provide service for the heater filaments. Now I'm going to start plugging everything into the Variac, doing a final inspection. Variac to isolation transformer. We're going to be doing a dry run with no tubes in the system. I've loaded up about 43, 44 volts we're seeing now. I just want to test the on-off switch right quick on the front of the unit. We're in the filament voltage right here, is what we're seeing. Okay, so there's power off. On. We also have the ground switch. Run that back and forth a couple times. Very good. 43. 62 volts. We're at 94 volts. At 108 volts, I got a little bit of a hum coming from the transformer. There's no load on the transformer right now. This may be the low voltage tap, I'm thinking. 113. It's 120 volts. So 120 volts producing 5.38. There's no way that it's going to be this tap. So I might as well shut this down and move to another tap. Switch it over to the next tap, and now we'll fire it back up. And this is the 7.17 volt. This is at 118 volts. The pilot light is shining in the front of the amplifier. Let's see what consumption is. 8 watts. What I would like to do is first make sure the amplifier is in standby. What I want to do is lower the voltage on Variac to ensure that the filament will not exceed 6.3 volts. And I'm going to control that, right? And I want to populate this with tubes and bring it up with this setting. And then see that with all the tubes loaded, when it hits 6.3 volts, what my voltage is on the AC. And if I come to find that I'm at 120, in and around, then great, this is the tap. But if I'm sitting at like 110, then I know I have to go to the third tap. So we're going to do that now. We'll point out really quickly before I do anything, while I'm here, seeing 33 volts, that no doubt looks like the bias voltage, expected 35, so not far off. Seeing 377 positive DC and plate 503 unladen, right? So I am seeing good voltages rectified, right? This is a solid state rectifier. So I wanted to point those out right quick for the record before I start loading this thing down. So got that out of the way. All the tube sockets are populated. I now have the multimeter connected to the pilot lamp. I've got the Variac turned down to 70 volts. I've got the amp in standby, so I don't need to worry about the disconnected reverb tank or the lack of a speaker. And I'm going to fire it up now and see what kind of voltages we got with the heaters. I think I may even, let me see. Yeah, I'm going to shut the lights out. Also want to point out that while I have this test going, I figured I might as well put in the current meter too on one of the finals, so I did that as well. It's off camera. Here we go, the first time in like who knows how many years. Now I'm going to take my time with this. I'm going to bring it up slowly. There's not nearly enough voltage to turn these tubes on just yet. See where the safe voltage. Bring it to 90. I do see glow from the 6L6s. I can't see all the way back to the other tubes right now. a look at the wattage. 30 watts. I want to stay on point with the voltage. 86 volts showing 4. We're at 102 volts right now. 4.8. I could hear all the tubes heating up, the glass making noise. We're at 109, showing 5.2. We're going to get awfully close here. 115 at 5.5. 120 at 5.9. Might be a little cold. I wonder if I could get another wrap on that cable, because I knew it was going to be pulled down once I started getting actual equipment on here. And I have to check for a sec. I have to make sure every tube is lit. It's extremely important that every tube is lit here, because each tube is going to bring down that voltage. Every tube is lit, so this is the pull down. So what I'm going to do is I'm going to let this run for a bit, and I'm going to see I have enough cable to wrap it a little further. I've wrapped another 2.5 turns onto this transformer. Got everything tied back down, except I didn't put the cover back on. I just want to put this tube back in that I removed while I was working, so it didn't get in the way. So I'm at 120 volts now, full complement of tubes. I'm looking at 6.2 volts on the filament. I really could not ask for anything more. This is about as close to perfect as perfect could be. This is what I'm going to do. I'm going to let this run for a bit. I'm going to get out the infrared light, and I'm going to monitor the temperature of the cable. I don't believe that this cable will represent any issue for the type of tubes that are in here. Most of these tubes pull nothing. I think like 50 milliamps or less, and just some of them are, just 2 of them are heavy hitters here, and even those aren't too terrible. This is not exactly a high current pulling filament system in this amplifier. Nonetheless, because I've modified from the original, I'm going to monitor this. This thing's running about 25 minutes, is barely breaking a sweat. Most importantly, of course, are the lines on the outside here that I installed. That's absolutely fine. They're not getting hot at all. They're not even warm to the touch. In the meantime, the covers are being prepped for painting. Have the covers here hanging, drying outside. This one's just about ready. The other one is still wet. Got the cables for the reverb tank pulled back through. I'm just going to resolder them into their original locations now. I've got the reverb tank connected. It's time to lower this thing back down. So a super quick test of continuity through the speakers shows resistance, just regular resistance of 6 ohms. Okay, so that seems about to be expected for this setup. Impedance dip right here. You can see we're sitting at 7. 5, drawing up, drops as low as 5 on the scale at 6. You see 4.5 at 7.5. We start to climb back up. So it looks like seven and a half ohms impedance. So about the 8 ohm speakers in this combination. We can see on the top side of the chassis, I've added the shell for the left side of the transformer. It's all painted and shiny, very nice looking. The reason why I added it is because I needed support for the transformer. I just can't have it floating. So I put that side on for now. Obviously still working with this side. That's absolutely fine. So as discussed before, I am going to put this potentiometer into the cabinet, and I've never really been hot about modifying original cabinets. Here's the thing. A very popular mod on this cabinet, as shown here, was replacing the hardwired speaker that originally just came straight out of here and putting the speaker jack on here and on the end of the plug that I just tested for impedance, right? The funny thing is that there are 2 of them. There's no need for 2. There shouldn't be 2, right? So if it turns out that it's just the same thing and serves no other purpose other than there being 2 outputs, which doesn't make any sense to me because that would change the impedance of the output. It wouldn't match. I would just remove one and replace it with this potentiometer and be done. I wouldn't even have to drill the chassis. Let's take a look, see if we can remove one, and that'll be it. Okay, so it looks like this output transformer on here is not original by any means. And also I found this floating wire here. Just the hits just keep on coming. So we're gonna have to see what's going on with this. So there are some outputs provided, but I need to know what they're for. What's going on here? What is this? No, both of these green wires are coming straight off of this connection right here. It's all it is. It's just a copy. It's just a double. Cutting it right out. There's one. And here's the second one. There we go. Now we have a connector that goes to nowhere. I could rip this one right out. And then we have an available slot to put our potentiometer. I don't get a lot of freebies on this amp. This was one of them. Found this disconnected orange wire way down here. This is this signal wire going from this finals tube to the audio transformer. So I managed to reconnect that. That would have been fun to find later had I not looked under there. Potentiometers are now wired in topside. We could lay this back down again and we'll do a temporary connection up top. Make sure everything is working okay. Now we can see the new adjustment in place right here. I'm gonna have to center that again. And it's like it still looks crappy up top, but it looks a little less crappy every time. It's getting better and better. This is a good stopping point. I now have a single input. We know that there's good impedance on the speaker, so we don't need a dummy load. We could just actually plug the cabinet directly in, and maybe we could bring it up without having it in standby. We could slowly turn it up on the Variac, monitor the voltages, then maybe tie in a function generator onto the input, see what we get. Just go for gold. I should also point out that I'm running this setup with one known weak tube here all the way at the end. I don't remember the function of them based on their order. I do have for this lineup as follows. I do have, this is the filament again up top here, AC. I have the speaker cabinet plugged in. It's just to the right of the camera. I have the current of the left finals tube. I have just off camera is an 800 hertz signal going into channel 1. Variac is on at 0 volts. The standby switch is set to off right now, and I'm going to start bringing this up ever so slightly to about 60 volts. Let's just do that. You see the voltage rising? Monitoring everything. The thing is, I want to bring it out of standby while it's still in the lower voltage, just in case something goes wrong. I'm thinking about half voltage, so 60. So we're taking it out of standby now. The threshold across, there we go. I'm getting 35, it's a bit high. 36 on the final, I'm not even, yeah, wow, 40 milliamps. 47. I mean, granted, it's idle, but you get up to 120, see what we're looking at. Get 117 showing 52. These things would most definitely red plate, given the opportunity, even though the voltages are correct. I just want to see if I get a sound through it. Oh, there it is. Bias is way off. The amp has come alive. We have got to look at that bias. We have got to look at that bias. Jesus, 53. This current's still flowing when it's in standby. I find that to be oddly strange. I want to see what the other tube is. This one's about 40. For those of you patiently waiting for me to figure out when I was going to tie the ground off to the humdinger here. There it is, wait no longer. There is the ground, and maybe proper in fitting, I used the original center tap ground wire I ripped out of the original coil winding for that ground. I brought it all the way up to the original star ground point here to further reduce hum. A repair like that is worthy of turning the amp on again, so I'm going to do that now. Now the hum pot is working. Maximum, minimum, maximum. I really need to get this shield on this side. I have a feeling that a lot of this noise is just radiating into this side of the amplifier because it's unshielded. Here's the filament connections cleaned up. These got shrink wrap and electrical tape. The electrical tape increased the sturdiness as I tuck it in to put the cover back on. The other cap back on now. I'm going to have to loosen the other screws to be able to slide it over and fit it properly, but at least I'll be able to test now and see if it reduces any of the hum now that it's no longer radiating into the preamp section. I really got to replace these or clean these. These are nasty. I want to measure bias by side, not just by tube. Left side is showing 43, which is absolutely terrible, but let's just go with this. 43 on the left. Now I'm seeing 54 on the right. This has to be the next thing I deal with because this is just beyond terrible. And we're going to go through the way the bias is set up on this amp because the way it's done on this amp is less than desirable. So here's a nickel tour of the bias here. We have a single diode, goes to filtration here, 100 microfarad capacitor, comes up all the way here to the center point. We have two 330 k ohm resistors split off, go into the grids of the 6L6s. Okay, given proper voltage right over here before it goes into the resistors, we could assume that if everything's okay with the tubes, the resistors were off. The resistors are the only means of adjusting the bias, which is quite terrible. You look at like an ST70 or something with a similar setup, it would have these resistors, but there would be potentiometers to fine-tune what the bias would be. You look at any amplifier, really, would have potentiometers to set this up. Also going to point out, hey, look at the standby. I was talking earlier about there's still current flowing on the tube at idle when the standby is on. It doesn't cut the voltage to the grid, right? Standby switch is over here by the where the looks like the inputs to the tubes here from the phase inverter. It just nulls it out, right? Wow, that's something. So that question's answered right there with the standby switch, and we'll take a look at that on the amplifier itself. But we're also going to take a look at these values right here, see what's going on. Really quickly, our visual inspection, we can see this is the standby switch, and it just open and shut, single pole, single throw, and it goes to pins 5 of the two tubes here and ties them together, right? And it also branches off. Here's an example of a pin 5, this light and dark green. One of them goes to standby. The other one makes its way up here. And we can see we got two resistors, a diode, 100 microfarad capacitor tied off on the negative side. So it's grabbing the, we got a connection coming up here. It's grabbing the negative side of the sine wave, right? Negative phase of the sine wave, and it's filtering it. And that is what is becoming the negative bias. And then there's a drop here on these two resistors. It's really cheap that they don't use a pot, but whatever, and that makes its way out individually on each side to the two tubes. Let's take a look at the values of those. Both 330s are measuring 360, so they have climbed, which is expected. What I don't know in this configuration is how much that climb would affect the grid bias. So what I'm going to do is I'm going to make an adjustment right here on these and bring them back down lower to their specification value, just because I want to know what the bias would be if they were within specification. So here's what I did really quick. I shunted 5 megs across each side, brought it down from 360 down to 336. Not perfect, but it'll give me an idea about how much dropping the resistance down that much affects the bias. And here's what the connections look like inside. This is not something I would call operationally ready for playing a guitar, but it's good enough for testing with the meter and taking a look here at the current. Amp is running, we'll let it warm up, we'll see what it comes up to. It's showing 50. Let's compare it to before. I'll give the before values. My friends at Cornerstone graciously provided me with a number of different types of 6L6s. And I have put one in the socket for measuring current. Now check this out. Okay, this is down 1 volt under specification, or negative 1 volt, if you would, right? And if you look at this, this is running at 24.5 milliamps. I'm going to test with the other tubes for consistency's sake. This first tube, by the way, is NOS RCA tube that I'm using. Take a look at that. So just to capture these one more time, I'm seeing 37.6 milliamps and a bias 35.2, and this is using the original rectifier. It's fluctuating. I'm seeing just about the same thing with my bridge rectifier, so I could put this diode back in. This is fine. Soldered back in. We give it one last test. It comes up. See 35 volts bias, and this one showing 35 milliamps. Yeah, not wonderful, but this will get us through testing now. At least it's not 50 anymore. This side showing 37, 38. It's now at a place where I could run this thing and not worry about blowing anything up. This is in the safe zone, so I'm going to continue onward. I'm going to come back to the bias and refine it later, but I'm not going to do it now. I'm going to move ahead. So the thing is dead quiet in standby. I want to talk about standby for a moment, because standby is about as stupid as the bias on this thing. And like I said earlier, it just cuts across pins 5 on the input there, right? And you could read bias right across the standby switch, actually, if you wanted to get a good value for the bias reading while standby was shorted. What I'd like to do is take it out of standby and pull the 6FQ7, see what's going on here, see if there's any voltages that come in here that leak through these capacitors at 14, 15. Right now, you could do anything you want to this one. See that? That's gone. When I take it out of standby, I do hear hum. Right? There's no circuit here. That is to say that there's nothing that extends beyond the coupling capacitors here. Begs the question if there's any DC leaking through 1415 worth checking. You hear that right there. Now, if I throw a standby switch, that's gone. You put the tube in, lets everything through. I don't even know about that first stage. It's noisy. That needs work, but I know that definitely stuff is getting through before that stage. It's time to investigate. And this cap turned out to be okay up to 600, but I did have to remove it from circuit in order to get an accurate reading. So I want to talk about what I got set up around. This is input to 6L6. This is pin 5. And this is what I'm seeing. I've got the amp in standby right now. I'll point out that standby kind of just, like I mentioned before, tries to null out the phase inverted signals to provide you what is reasonably quiet, right? So I'll just say that standby just is kind of like a mute. That's all there is to it. But we're not really going for that, right? I got this thing turned up here. But what I want to show you is this. I'm going to take out that 6FQ7, the phase inverter. I'm just going to pull it right out of circuit. And this is what I'm now seeing, right? With them tied together, like still in standby. Dead quiet. I wanna watch this for a while, right? Because this will tell me that all the way up to the 6FQ7, there are no issues, no crackle, no weird artifacts in the final stages, and I can work my way back. It also tells me I definitely got problems that I work my way through this phase inverter. That is dead quiet. And I realize when we talk about dead quiet, obviously there's no input signal, but it also means there's no DC getting through, or very little. I mean, I'm reading nothing. I'm reading just about nothing. So there we go. I'm popping the 6FQ7 back in, and we can see that noise come back, right? And on the 6FQ7, the input into this from the previous stage, the 12AX7, is on pin 7. So I have a connection here to pin 7, and it's floating right now. Right, watch this. When I ground it and take it out of standby, one channel is not the same as the other. Something is wrong here. You see that? Not all things are equal here. And we can see that whatever's happening, even though it's grounded, that input on 7, that something is getting through one side of this phase inverter. So let's magnify. I'll reiterate, the signal is grounded. The input to the phase inverter is completely grounded. Now we need the channel to 20 millivolts going to the finals. And we could see to one tube on the bottom, it's almost dead quiet, right? Real magnification here. The top one's very noisy. We have to find out why that is. Why is it on that circuit?